All right, folks, lesson 4. If you guys could quietly end your conversations, please, and we'll start. All right. Guys, focus on me now, Trinity. So we need you to go to this section and look at the terminology they're using. Right here, this word here, regular polygon. Okay? Make sure you highlight that one. It will focus on me, please. The regular polygon, that's when all the sides and all the angles are the same. So like on your quiz today, remember you had to work with the equilateral triangle? That would be the regular three-gon. You guys understand what poly means? What's poly? Poly. Many. So when you say polygon, what they're saying is like many gone. So like when you say triangle, it's really like a trigon or like a three-gon. And then like, you know your quadrilateral? Like the square is an example of that. That would be like a four-gon. And then like the pentagon, this is like five-sided, right? So that'd be like a five-gon. And yeah, penta means five, yeah, so pentagon, yeah. Norvisi, could you put your phone in your pocket or something? Yeah, decagon, deca means 10, yeah. Hepta, what's 12? Dodeca. Dodeca, yeah. All right, so if we take a look at these pictures, we can fill out this chart. So let's start with the triangle. Let's start with the triangle. Please focus on me, please. Guys. So let's start with the triangle. Look at this. Those are all the radius of the circle. Do you agree? So we're basically chunking this into 3 sections. And the whole rotation around is 360 degrees. You agree with that? So then because we're partitioning it into 3 sections, you can divide that 360 by 3, and you get 120. So this is 120, this is 120, and this is 120. Norvisi. No, you're not. So because those triangles were separated into these 3 chunks, like this double tick, this, they're all the same, right? Because they're the radius of the circle. They're the radius of the circle. So that means you have isosceles triangles in here. Do you see the isosceles triangles? That's the same as that. So that blue triangle is isosceles. So of the 180 that make up the circle, take off 120 from 180. What's left over? 60, right? And you have to divide up the 60 into these 2 corners. So this one's 30 and this one's 30. You can't zoom in there? Do you guys just want the bare bones of this? Okay, let's just do it on the side. You already know that in a triangle, they add up to 180, right? You already know that one. What about a quadrilateral? Let's use the rectangle, for example. In the rectangle, what do they all add up to? So what's the pattern? How much did it go up by? It doubled, sure, but like how much did it go up by? 180. Let's try, what if it was like the pentagon, the regular? Remember that, and they all have to be the same. What do you think they add up to? No. Good, 540. Why 540? Another 180, good, because it has one extra side. So like in a three-sided figure, all the angles add up to 180. In a four-sided figure, all the angles add up to. In a five-sided figure, all the angles add up to 540. And in a six-sided figure, they're going to add up to 720. So you can draw the hexagon if you like. Yeah, hexagon. So this is the hexagon. It'll add up, all of them will add up to 720. Is that good enough for the first page? You want to do the chart? So we can do the chart together if you want. In the pentagon, there's 5 sides. The measure of the central angle will be 360 divided by 5. 360 divided by 5 is 72. So for the 5-sided figure, this guy is 72. So what does that leave for the rest of this in the isosceles triangle? Well, you'd have to subtract from 180 and then divide by 2. That's what they do here. 180, take away 72, get that result, and divide by 2. 108 divided by 2 is 54. Okay, so this guy's 54. This guy's 54. This guy's 54. This guy's 54, and so on. But more importantly, what they want is the actual angle of the pentagon, one of the angles on the pentagon. So you would have to double up the 54. 54 times 2 is the 108. So this is 108. And then because there's 5 of those, what's 5 times 108? This better be the 540, or else I've lost my mind. There it is, 540. And now you see the pattern here. You just continually keep adding 180. You just keep adding 180. Okay? All right, so is there any questions about this? To which spot? On the chart? Nonagon? Oh, hexagon, because it has 6. It's a polygon with n sides, where n can be any number. All right, let's keep going. Okay, this is the formula on your data sheet. Okay, on your formula sheet. So that formula, again, it's going to measure the total of all the angles in a regular polygon. So for example, equilateral triangle, what would you put in here for n? For an equilateral triangle? What would you put there? 3. What's 3 take away 2? 1 times 180? All the angles in a triangle add up to 180. Okay, let's try the next one. Let's try the square. Because remember, they have to be regular polygons. So that means all the angles and all the sides are the same. What would you put in for n for that one? This one would be n equals 4, right? Plug in a 4 there. What's 4 take away 2? 2 times 180? 360. So all the angles in a square add up to 360. So is that formula pretty straightforward? Okay. What if it was an irregular polygon? Is it going to be the same? It will be. You know this one's 180, right? So the next shape is a quadrilateral, but they put it into 2 triangles. 180 plus 180 is? The next shape is a 5-sided figure, like a 5-gon. And you can create 3 triangles with that. Good. 180 plus 180 plus 180, 540. So it doesn't have to be a regular polygon. It doesn't have to be a regular polygon. Yeah, it's just how many triangles you can fit in there. So like, let's just do one together. And we form triangles like this. How many triangles did I create? 1, 2, 3, 4, 5, 6. Oh, it glitched. So each triangle has a sum of 180 degrees. And how many triangles do I have? 6. So 6 times 180 is 1,080. So can you try to use the formula on this one? Like, let's try to count the sides. Let's just count the sides. 1, 2, 3, 4, 5, 6, 7, 8. 8 minus 2 would be the 6, and then you times by 180. Okay? So any issues with that formula? Oh, that's the formula? Yeah, like so what he's saying is the process has to start with the triangle. Because if you only have 2 sides, you don't have a closed shape, right? Like if it's just 2 sides, it's just an angle. Like if I tried to do n equals 2. Yeah, and then the first one in the pattern is the triangle, so it has to be 180. Okay? That's a good question. I like it. So we can go through this. Like pentagon would have 3 triangles. 180 times 3 is 540. How many triangles would the octagon have? You just follow the pattern. The number of triangles is always 2 less than the number of sides. So good, 6. And then you take those number of triangles and times it by 180, because that's how much each triangle is worth. I think we already did this one. Yeah, 1080. Okay, and so on. You guys okay with that? Now this page is a little bit daunting. By far this page is the hardest part of this lesson. This one here is, this one here is the main formula for this section. Now I just want to talk about what would happen if you found the sum. So this is the sum. But I wanted to know what each was worth. So like, let's do the square, for example. What do all the angles in a square add up to? 360. Now, I'll highlight this for you. If it's regular, like a square is, then how would you figure out how much each one is worth? If they're all the same, you'd have to divide by 4 because there's 4 angles. So that's why they have this one here. I wouldn't even look at that one because that one's like the simplified version. You don't even know where that one would come from. But like, let's look at this formula on the side here. Here's the total, and here's how many I have. So then the result of that will be how much each angle is worth in the regular polygon. Okay? Yeah, come on in. Okay, so like for ours, let's do an example for the one we did. We did 180, 4 minus 2 divided by 4. That would be 180 times 2 divided by 4. 360 divided by 4, 90. That's the one we did. Okay? Okay, so then you can get, I wouldn't use this one. I would use this one here. The interior angle of an n-sided regular polygon measures this. Hello, sir. Oh, yeah. Okay. So those two I'm going to test. For sure I'm going to test you on those two. I'm not going to test you on these ones. Okay? I'm not going to test you on these two. So you can put here, not on test. Absolutely. Because it's not on your formula sheet and you're just not going to remember it. And it's like useless stuff that you're not going to remember. But the first two with the stars, you're going to get tested on that. Because there's simplified formulas that are not on your formula sheet that you're probably not going to memorize. So I don't want you to, I'm not going to try to force you to memorize. Like at least this one, you could think about it. First of all, the top part of the formula is on the formula sheet. And if all the angles inside that shape are the same, you just have to divide by how many angles you have. Okay, so divide by how many angles. Can we try some of the questions on the next page now? That's all I need. All right. Calculate in degrees the sum of the measures of the interior angles of a polygon with 9 sides. Okay, first things first. If it has 9 sides, n is 9. You jump to that formula that's in your data sheet. 180 times n minus 2. You can plug in where you see n, a 9. 9 minus 2 is 7. You do brackets first. 180 times 7, 1260. In a 9-sided figure, all the angles will add up to 1260. Number 2. Now it says determine the number of sides. So they're saying, okay, n is the question mark. And they give you the 4140. So it's the exact same formula, but you got to work it backwards. So 180 n minus 2 is equal to 4,140. Like this question will be on your test. This class example 2. It's easy to it's easy to prepare for, and it tests your algebra ability at this level. This is very doable at this Math 20-2 level. I want you to think about how you could solve for n. Right now, n is like locked in that bracket. So how could you unlock that bracket? You could distribute. Would you guys, are you comfortable with distribution? Good, Yasin. What could you just divide right off the hop? Good, Michaela. You could just divide 180 if you liked. You could divide 180 on both sides. You could also distribute. That would also get you to that as well. So let's divide by 180. Why am I dividing by 180? Because it's 180 times n minus 2, and the opposite of timesing is dividing, and you can divide by 180 on both sides. And what do you get? I wish this would just default to the black. Come on. So you get n minus 2 equals 23, and therefore n equals 25. You just have to add 2 to both sides. So you're going to see these 3 on the test. For sure you're going to see those 3. Now it says determine the number of sides of a regular polygon whose interior measures 170. So this would be a shape, a regular shape. So all the sides and all the angles are the same, and that angle's 170. So when I go to do this one, what does that formula represent? What does that formula represent? The angle what? The angle sum. But I don't want the sum, I just want one of the angles. So what do you have to do to that sum to just get the value of 1? You have to take the total and divide it into all the sections, right? So you have to divide by the number of angles. How many angles in an n-sided shape? N. And this equals 170. Now solving this one takes a little bit more gumption, a little bit more determination. Because there's more than one term involving n. So what I would recommend that you guys do here is multiply both sides by n. So times by n on this side, times by n here, times by n here, and you'll no longer have a denominator to work with. So let me rewrite this. 180 n minus 2 equals 170 n. Now this is where you want to take the distribution path. You can't just divide out 180 here. You're going to want to distribute. So distributing 180, because in the first equation, this one up here, there was no other mention of n anywhere. So I could isolate for n by just getting rid of the 180. If I divide by 180 on this one, I still have something with n over here and something with n over here, and it's going to mess with you. You could do it, but not sure you'd be able to. This is an easier path. So after distributing, 180 times negative 2 is negative 360. Now it's just a one-step or a two-step equation that you guys are probably pretty familiar with at this point in your life. So I'm going to move the 170n to the left and the 360 to the right. Notice that the 170 will switch signs when it goes across the equal sign. And the 360 switches signs as well. 180 take away 170. 10n. Now divide by 10 and you get like add 360 on both sides. Yeah, if you add 360 on both sides, one will be 0 and then you'll have positive 360 on the right. You know this, I know you do. Like all I did was this, plus 360, plus 360 like that. That's all I did. Oh, because I subtracted 170 on both sides. You know that stuff, right? Yeah, I just did it a little bit quicker. Now think about a shape that has 36 sides. A shape with 36 sides, and they're all the same. How many would you have? Well, this shape is pretty much going to approximate a what? Yeah. So that's why each angle's so large, right? It's literally almost a circle. Like if you had a 100-sided shape where they're all the same, it's pretty much a circle. And that is actually how they define a circle. It's like an n-gon where n is equal to infinity. Cool. Now we're not going to do class example 4, but we will do 5. Now this one will be on the test for sure. It's going to be a connection of geometry and algebra. So for class example 5A, this one's very doable. Like how many, first of all, what type of shape is it? How many sides? 1, 2, 3, 4, 5, 6. So I would go to that formula. 6 take away, oh gosh. 6 take away 2, multiplied by 180. 4 times 180 is 720. So what do all those angles have to add up to? So then you just need to take away those other ones from 720. So that's the interior angle sum. Therefore, x is equal to 720 minus all those other guys added up. So I'm just gonna add these guys all up. The sum of the rest. I'm just being lazy. I could write them all. Schonard did it for me. He added them all up and got 600. Thank you, sir. This is 600. All I did was add those all up. 720 take away 600 is 120. So this little guy here, x, is 120. Okay? So I'll give you guys about 25 seconds here to take a deep breath, because this next question, tough. I'm not going to move it. It's this next question that's tough. Yeah. Just wait like 2 minutes and then you can go. Just like 2 minutes and then you can go. Well, that's too bad. Oh, you're doing some community service? Can I move it now? Okay. Let's focus in on this triangle, or pardon me, this shape, pardon me. Focus in on this shape. You need that back? So let's do this one and I'll put it back. I promise I'll put it back. Okay. So let's take a look at this irregular polygon. And notice that each angle is given an expression. Right, Ozzy? Each one of these angles is given an expression, except for one of them. Which one? This guy, right? How could I get that guy? What's the number one commandment in like Christianity? Thou shalt not kill? I don't know them very well, but is that the thou shalt not kill? Pretty sure it is. Okay, so let's just pretend mine was correct. What would be the number one commandment in Math 20-2 for geometry? Which rule? Thank you. The straight line rule. By far, that is the most important rule. Hey, well, that is by far the most important rule to look for. So how could I get that one right there? How could I get that one right there? Take away from. Good. So this guy right here would be 180 take away a plus 20 degrees. Good. Could you simplify that? What's 180 take away 20? $160, right? And then what sign goes on the A? Negative A. Right, Norvesi? Right. A will. Put it in your pocket, man. Okay, so now we have all 5 of the angles. We have all 5 of them. 1, 2, 3, 4, 5. In a 5-sided shape, what should they all add up to? N take away 2 times 180. Trinity, Norvesi, focus on me, please. Not talking to each other. Thank you. 5 take away 2 times 180. 3 times 180 is N, yep. That's better. So all 5 of those angles have to add up to 540. So now bear with me. 2a plus 3a minus 40 plus a plus 12 plus 3a plus, and there's one more, the 160 minus a. Just to indicate that there's 5 separate angles that you're adding up. And what do all 5 of those angles add up to? 540. Good. So let me just get rid of that just for neatness. All this equals 540. You agree? All right. So 540 equals. Collecting like terms, how many a's do we have on the right? 2a plus 3a is 5a, plus another a is, plus 3a is 9a, take away 1a is 8a. Now add up the numbers. Negative 40 plus 12, that's negative 28. Negative 28 plus 160. 160 take away 28. 132. And it's a positive 132, right? Now, how to solve for a? We have to isolate for a. That means I need to do what with the 132? Move it to the other side. And now you have this basically done. 8a, 540 take away 132. 408. Now you divide by 8, divide by 8. A is 51. Okay. There will be one like that on your test for sure. This page, very important page, except for class example 4. So put a star on this page when you're studying. This one's going to be important. And I apologize that that took so long. Oh, you want that spot back, right?